In this video, we're just going to do the second derivative test for finding relative extrema. So just a quick review here. The second derivative f double prime tells us the concavity of the function. So if f double prime is greater than 0, as you see here, we're concave up. And if we're concave up, we generally have this shape going on here. So that means we would have a minimum going on. And if the second derivative is less than 0, we'll have concave down, and we'll actually have a maximum. And if f double prime is equal to 0, then the test itself is inconclusive, but it can be an inflection point. It doesn't have to be an inflection point. For example, if you have like a slope, like a linear equation, the second derivative is 0, but you don't have any inflection points. And just a review, an inflection point is the point where it changes from concave up to concave down. Something right there. Alright, so let's move on to an example. Alright, so we have another polynomial. So let's just find the first derivative and the second derivative first, and see if we can find any relative extrema. Again, just using the power rule. There's 3x squared minus 3. And the second derivative, again, just to use the power rule. Now we have just 6x. Alright, so let's find the critical points. Now for polynomial, the critical point is when f prime equals 0. But for other functions, it's when f prime equals 0 and when it's undefined. Again, since we have a polynomial, we'll just stick to f prime of x equals 0. So 0 is equal to 3x squared minus 3. And we'll just use factoring as our technique to find the zeros. Let's take out a 3, and we'll have x squared minus 1. And as you can see, that's a difference of squares. So we can just further factor that. That's x minus 1 quantity times x plus 1 quantity. And then you should be able to see quite clearly that our zeros are x equals 1 and negative 1. So those are our critical points. Now again, we're going to use the second derivative test. So we're just focused on f double prime of x, which is equal to 6x. And our critical points are x equals 1 and negative 1. So now for the second derivative test, we're just going to plug in our critical points into our second derivative. So f double prime of 1 is 6 times 1, which is just 6. And we have a positive value for our second derivative. So that means we're concave up. And if we're concave up, that means we'll have a minimum. So min at x equals 1. Now for f double prime of negative 1, again, it's just 6 times negative 1, which gives us negative 6. So that's concave down. That means we'll have a maximum. So max at, let's see, x equals negative 1. And that's it there. That's the local extrema for this function. And we'll go over harder examples in the next few videos.